Computational thinking, what is it and how should it be taught? Computational thinking is prevalent in the national curriculum, which states that a high-quality computing education equips pupils to use computational thinking and creativity to understand and change the world. Berry comments that this puts computational thinking at the heart of the curriculum's ambition. So what is it? To address misconceptions, computational thinking is not thinking like a computer or thinking like a computer scientist. Moreover, computational thinking is the process by which we use our knowledge of what computers can do in order for them to help us solve problems. Barefoot Computing adds that this computational thinking is learning to think in ways which allow us as humans to solve problems more effectively and, when appropriate, use computers to help us do so. Brennan and Resnick explain that this is not much of a simple term. Google's definition comprises of 4 elements: decomposition, pattern recognition, abstraction, algorithm design, and debugging. Teachers could argue that these terms are too complicated to be used in the primary school. However, development of vocabulary is essential in all subject areas, and as Berry highlights, phrases like split-valve digraph are used in reception, so I-word words such as algorithm pose a problem. In contrast to Google's model of computational thinking, Berry provides a developing definition that includes tinkering, collaborating, creating, preserving. However, for simplicity, Google's model will be used. Decomposition is the process of breaking down a big problem into more manageable segments. Barefoot Computing states that this helps us solve complex problems and manage large projects. Berry adds that a task can be tackled by a team working together, each bringing their own insights, experience and skills to the task. For example, when making a game in IT, each person would have their own role, whether it be sound effects, theme, graphics or computer think. Decomposition can be used and taught in other subjects, for example in maths when using grid method to segment complicated multiplication sums. Secondly, pattern recognition. Pattern recognition is the ability to identify similarities in something. This process is taught throughout the curriculum as recognising patterns helps pupils better remember key ideas and concepts. For example, in literacy, pupils recognise the pattern of certain spelling rules, or in maths, pupils must recognise the pattern of multiplication facts in their times tables. Abstraction. Abstraction is about understanding what you really need and what you can leave out. Barr and Stevenson describe it as simplifying from the concrete to the general. Solutions are developed. Learning abstraction is a vital concept as often pupils must simplify their work for better outcomes. For example, shortening a persuasive letter by removing excess details, or in drama when preparing for a nativity play, understanding that a real baby is unnecessary and a baby doll would be adequate. In technology, an example of abstraction is how the design of the bird in Angry Birds has been shortened into a round circle with a beak and eyes opposed to an actual bird shape, emphasizing the idea of simplicity within creation. Algorithms. An algorithm is a sequence of instructions or a set of rules to get something done. Teaching algorithms doesn't have to be confined to computing. Algorithms are present in everyday life, school routine, following a recipe. In practice, pupils could physically write an algorithm in order to get a better understanding of how they're doing in their work, for example making a jam sandwich. Berry argues that this non-computing method makes it far easier for them to get feedback from you or their peers on their algorithms before implementing these as code on their computers. Knowledge of algorithms is then transferred to the use of Bebots or Scratch for programming. Lastly, debugging, the process of correcting errors in the programming. Correcting and learning from mistakes is an essential component in all learning, whether it be spell checking in literacy or correcting an error in a painting. All these aspects comprise to make computational thinking. From the evidence above, it is clear that computational thinking should be taught across the curriculum because of its implications for not only an understanding of computing, but an understanding of all logical reasoning and problem solving. Barr and Stevenson emphasise this by stating that the power of computational thinking is that it applies to every other type of reasoning. In addition, computational thinking requires pupils to think both creatively and critically. In future practice, I would link creativity and computational thinking together by using programming software such as Scratch and introducing large IT projects to be worked on in groups. Ultimately, the ambition is to understand what the computer can do for us and how we can use this criteria for our own creations and problem solving in day-to-day life.